Hello everyone, I am Pushpita Chandra. I'm a PhD student and under joint doctoral program of University of Queensland and IIT Delhi. So I am the TA for this NPTEL course, Introduction to Lasers and Laser System, and this is the second tutorial. Introduction to Lasers and Laser Systems. So in this week, professor has discussed these points. One is the different kind of pumping. Second is basically what is the problem on 2 level, 3 level, and 4 level. No, there is no problem with 4 level laser system. Basically, why we need 4 level laser system. Third, he has discussed some basics, behavior of light, this reflection, refraction, total internal reflection. And fourth, he started the concept of interference. Just started the young double slit experiment. First, I will go through everything briefly, then I will discuss some previous year quiz question and some extra questions. So, why do we need pumping? We need pumping for create population inversion. So without the population inversion, we know there will not be any lasing action. So what is the population inversion? If the number of atoms at the higher state or higher energy level state or excited state is N2, and number of atoms in the lower energy level state or down state is N1, population inversion would be when N2 is greater than N1, which is counterintuitive state. Like we know without any stimulation, everything would be in ground state. So for that is why it is called inversion. So to make that happen, after the population inversion, there's an action will start. But to do the population inversion, we need pumping. Pumping means to pump the atoms from the lower state to higher excited state or upper lasing state. This is a process called pumping. So here in the class, first pumping method that has been discussed is optical pumping. So basically, what is optical pumping? That by the optical method, the pumping happens from the ground state to excited state. And the optical pumping method is mostly used in like solid or liquid active medium. It is easy and it is fruitful. So in this method, like this is cavity, this is an active medium. So incoherent light need to fall on this active medium. So then the atoms will transition from ground state to higher energy state. But with the gas medium, the optical pumping is not that efficient. And why? Because we know that with the gas medium, most of the volume is free. So the photon can miss those atoms or ions in the active medium to give the like lazy reduction. So here active medium for solid or gas or optical pumping, incoherent light is needed. And then we will get coherent light. Like, this is partially silvered mirror, so we get coherent light from this direction. But for optical pumping in solid or liquid, sorry. But for gas, we need to pump it if we want to use the optical pumping, the coherent light. So to use the optical pumping in a gas optic medium, need another laser first to produce a coherent light. Then it can do produce coherent, like we to use optical pumping in a gas active medium laser, we need another process to produce a coherent light. Then we can use it as a optical pumping. Then comes electrical pumping. So what happened that this is like atoms here. That is E is equal to E0. And this is the control red or green as per to follow the convention professor has been using. Okay. So in this electrical pumping, population inversion has been created. Population inversion has been created with electrons produced in a high voltage discharge, and these electrons collide with a velocity v collide with these ground state atoms and transfer their kinetic energy to this ground state atom, and they goes to the higher state. And these are all inelastic collision. Remember, these are all inelastic collisions. So after these collisions, the ground state atoms goes to higher energy state, and these electrons lose their sum of kinetic energy, so their velocity changes. So this electron goes out of the system with another velocity, that is v dash, and now there is less number of atoms or ions in the ground state. So this is how population inversion got established. So this electrical pumping is mainly used in the gas medium because of like the property of the gas, that most of the space in the gaseous medium is already empty. So to be more efficient pumping method, we need electrons, a large number of electrons. And these optical and electrical pumping are the most uh, popular pumping scheme in the field of laser. But there are other different kind of pumping scheme that they are not popular, but they are very particular to like a particular lasers. We can use that. So one is gas dynamic range. Pumping. So in the gas dynamic pumping, what happened that um, the temperature, we increase the temperature of the active medium. So when the temperature is in room, is in with as per with the room temperature, the population of higher energy level is like 0. But when the temperature rises, the population of this levels become non-zero. And now, when the higher energy levels are fairly populated, we just cool the system. So when we cool the system, like not all the energy levels at the same time of same amount of relaxation time. So see that see there are different levels like E1, E2, E3, E4, E5. So some they are like So it may happen that the E is to quickly relaxes to E naught, and this E3 relaxes to E2, E4 relaxes to E2, E5 relaxes up to E2. But E2 has more relaxation time. So the population here, all the atoms which were in E2, 3, 4, 5 are now at E2. And the atoms which are only at E1, they come to the ground state. So this is how the population inversion been established between E2 and E0. This is the method of gas dynamic pumping. Here is another kind of pumping, that is chemical pumping. So what happened in chemical pumping? So in chemical pumping between the cavity in the active medium, what happened? We make possible the reaction, chemical reaction. And as the product of that chemical reaction, some excited state molecular ion got made, or you can say got produced. And that excited state, so there were already absence of that molecular molecule at the ground state. But when we make the chemical reaction happens, the product is already in the excited state. So basically, even if one or two molecule being made out of the product as a product of that reaction, there is no molecule, same molecule in the ground state. So it is already creating the like population inversion, that for hydrogen fluoride is that hydrogen and fluoride being imparted, so we got hydrogen fluoride in exciting level, but there is the absence of neutral or ground level hydrogen fluoride. So that is how population inversion is being created using chemical pumping. There are different kind of pumping, also atomic pump, automatic pumping in the excimer laser. So here the inert gases has been used and pumping by energized nuclear particles. Has the inert nuclear particles emanating from nuclear fission or nuclear bomb. There are different kind of pumping, but they are very particular in nature, that you are not using that kind of pumping in everything. The most common practice is the optical pumping and electrical pumping. Now we go to like in nuclearly active uh, particles also. The kinetic energy is being transferred from this those highly energetic uh, molecular ion to the active medium atom or ion. Now, till now, we are thinking that, sorry, only talking about two level, E0, E1, or N1, N2, whatever. It is two level system. So we know that how this two level system, three level system, the names can interaction. The two level system is number of participant energy level is basically 2. When it is called three level system, it is 3 and all those things. So The two-level energy system does not do the lasing actions so much because like the population inversion has been created. First, the population inversion we will create, not being created. First, we discuss that here the atoms are here, only one atom. So when the light beam is being introduced, so it all are using population inversion. So whatever is the input beam, output beam is much less intense. So the medium is acting as an absorbing medium. So after some time, what happened? The population inversion is the population inversion is being achieved. So what happened? The whatever is the input beam, the output beam became more intense than previous stage. After some time, what will happen? The number of atoms in the upper state and the number of atoms in the lower state uh, will be equal. Then the probability of interaction with this photon, the input photon, is the equal with both upper state atoms and ground excited state atoms and ground state atoms. So the number of emission happens is equal to number of absorption. So we will reach a steady state position, but the lasing action will not happen. So that's why two-level systems are not the ideal case. Are not the ideal case now. Not like are not the ideal case. We cannot achieve the lasing action with the two-level system. There's no question about that. So for that reason, so let me put it in a writing brief. So these are all has been discussed in the videos uploaded for like a week two. So I'm discussing all this in a brief level, but for the sake of this, they see we I am writing this. In two-level system, there arises a situation where the atoms in ground state and excited state became equal. So the probability of absorption photon from emission photon is same. So after that population inversion, so after this situation, population inversion cannot be achieved. So no losing action. So for that, we go to three-level laser system. So what happened in three-level level system? We decouple that the pump level and the upper lacing level is not the same level. So these the things I am explaining. What is the problem with second two-level level system? What is the problem with three-level system? We can do all the mathematical calculation, the range of pump, that the rate of decaying, and include all those things in the equation, and then till the basic level why the using action cannot be happen. What is the efficiency of that system? And say that why it's not working mathematically. So this calculation has been mentioned in the book name is Lasers. So lasers by Ajay Katak and Thiagarajan. This is okay, an introduction to level. It's a Voyager contact with see them on the chapter 5, I guess. So by using pump, the atoms are being pumped from E0 to E1, and the air from E1 is a very highly unstable state. So from E1 to E2, the like atoms or ions, whatever be the case for that laser, they transit, and this is a non-radiative translation, and they come to the level E2, which is a metastable level. So that is how the population inversion being established between E2 and E0. But here is also a problem that E0 is the source state, source level. So if there are already very much of an atom, so we need to pump half of the atom, at least half of the atom to the pump level. So the pump power we need is very high pump power. And efficiency is not that good. That to maintain the population inversion, we need to like pump so much. So that's why we need four-level laser system. So let me write the So the advantage is lot of photon is consumed to form atoms or move atoms from ground level to palm level. And we need to, in order to keep the water, feed the population in motion, pumping should be very fast. But it is very expensive to pump in 3W system. So for that reason, to achieve easy and sustainable population inversion, we use four-level system. So for that, what happens? For us, in three-level system, the pump level and upper lacing level, we separate them. Now we separate the source level or ground level and lower lacing. So lacing action happens between E2 and E1. E0, this is upper lacing level. This is lower lacing level. So first, the ground state atoms, they have been found from E0 to E3. Then through some non-radiative radiation. So here also was a problem that the source atom, like after the lasing action, they come to the source level, and then again you need to pump. So here, what happened that from E3 to E2, the lasing action is non-radiating. So and the, E2 is the metastable state. So the atoms non-radiatively comes down to E2. Then between E2 and here is at first there is no ion. So already ground population inversion is established. So the electing action happened in E1, and after so many times, after like not so much time, like after some time, this E1's atoms also come down to E0. So again, population inversion has been achieved because E1 become like empty. So the population inversion between E2 and E1 became sustainable, and like it's easy to keep that in way. And the pump power we don't need so much now. So that's why we need 4-level laser. So basically first is the 3-level laser. We decouple the pump level and upper laser level. And the 4-level laser, we also decouple the source level and lower laser level. So we were needing extreme high level pump power because the source level and lower energy level, LSE level is the same level. So to keep the population inversion state, it was very hard. So the pump should be like the high power and very expensive. But here, see that we need to establish population inversion. We need to be E1 and E2. So an E2 is already empty when the lasing action starts happening. But after some lasing action, those atoms also non-repeatedly get down to the E2. So again, it got empty. So lasing action can happen. I mean, can be sustainable in that way. That after that, uh, professor has discussed some basic characteristic of light. First, the reflection. So what is reflection of light? Reflection of light is a phenomenon where light rays strike a surface and bounce back into the same medium, enabling vision and image formation. You have that. The light rays strike my surface and bounce back into the same medium. Enabling vision and image formation. And the law, which is more important than the definition, is one is the angle of incidence I and the angle of reflection R, and it has to be equal. So basically, this is I and this is R. They need to be equal. And secondly, the incident ray, the reflected ray, and a normal to the plane. Or depends on normal to the all. The incident ray and the reflected ray at the point of the incident on the surface. All lie or same plane. Okay. The reflection are typically two kinds. Regular reflection is specular. Reflection, and another is diffused or irregular reflection. So the irregular reflection occurs when once right parallel beam falls on like parallel beam falls on a smooth surface. So they follow the rules of like rule of reflection. They produce this specular reflection. So they form image, sharp image, and the object appear shiny. But if the surface is irregular, even if parallel beam falls over column that is kind of surface, at each point of incident, they follow the law of reflection. So the reflected beams are not parallel, they are diffused and they scatter in all direction. So they enable vision. And these objects doesn't they are non-shiny objects basically. So when the light falls at the interference of two media, basically some of the light got reflected and some goes into the second medium. Depending upon the whether the medium is like if this is the path, light doesn't follow that same path in the second medium. So your medium one is air, because one is one is water, it's water or class, depending upon which type of class it is. 1.5. Okay. So the medium 2 is more denser, so that is light will follow this path. And this phenomenon called refraction. And the Fresnel's reflection coefficient should only say reflection. Formula has been given by R is equal to mu1 minus mu2 by mu1 plus mu2 whole square. So in the case of air and glass medium, this would be 1 minus 1.5, 1 plus 1.5. So that is 0.5. 0.5 by 2.5. That is 0.2 of 20%. And there is also law for refraction. And that is first Snell's law that n1 sine I should be equal to n2 sine r. And second law is incident beam, refractive beam, and the normal at the point of incident all needs to be same thing. Now, from this formula, you can derive many things that we have seen that when light goes to here, I have shown that when light goes to one medium to another, depending on the second medium, if it is denser than the first medium, the reflected light will be more close to the normal. And if it is rarer, then it will be away from the normal. So we are discussing a particular case basically, which is here light is traveling from denser to rarer medium. So if light is going like this, it will be here more apart from that normal. So that means I. After some time, there would come an angle for that. This angle R is 90 degree. I. That angle called critical angle. So light will pass at the same level of the interference. And if we increase that incident angle, that is I is greater than that critical angle, then all the reflected ray will be in the same medium only. And that is called total internal reflection. So in all these cases, there is the actual reflected ray. Reflection is happening there, no matter what happened with the reflected ray, reflection is also happening. But in the case of total internal reflection, the thing is that there is no refracted ray in the second medium. Because it's going, light is going from denser to rarer medium, all the ray beam or beam of light is being in the first medium only. So according to law, we know that if this is N1 and N2, so N1 sine theta C for critical angle, N2 sine 90 degree. So theta C is basically sine inverse N2 by N1. And we know N basically, N1 is basically C by N1. That is the ratio of two velocities if that takes. There is a thing called retroreflection. So what is basically a retroreflection? A retroreflector is a combination of two mirrors inclined to each other at 90 degrees. So what happens that the reflected light always travel in a direction opposite to the incident light. So what happened? The light comes that way. It goes like this. So this kind of retroreflector helps in the measuring distance between satellite and the like Earth and all, between Moon and Earth. So that's their, what should say, that the utility. Another thing is called dispersion. Dispersion is when the white light falls on an interface due to refraction and different refractive index for different light, different wavelength, I should say, for different wavelength inside a medium. White lights split into 7 wavelengths. This is called dispersion. And for prism, it happens like happens that red red goes like this, and violet, okay, violet is this, violet goes like this. And all the like indigo, blue, green, yellow, orange, they come in between this. Another thing we need to remember that what is the use of total internal reflection. So we couple light in the fiber using this total internal reflection. So know that all our Wi-Fi, all our intelligence come from one place to one space to another because of there is very large number of fiber like at the seabed and other like there are 450 million kilometer of fiber around the world, which is which made possible our communication so fast. So we know that velocity of red is greater than velocity of violet. For that reason, the reflective index of red is less than the reflective index of violet. And for that reason, the angle, refracted angle, for red is greater than reflected angle of violet. So the reflective index is less for red compared to violet in a medium, but velocity and reflected angle is greater than the violet of the red. You can say about the critical angle. It is the critical angle for R is basically U to UR and critical mu and n, whatever you can write. And refractive for violet is 2 by mu v. We know mu r is less than mu v. So theta c r is greater than theta c. Critical angle in the line. What professor has dived into its Young double slit formula. Not formula, Young double slit experiment, which proves the wave nature of the light. So, professor has already given the, what should I say, background of this experiment. And he has not finished his discussion. He will continue his discussion in the next classes. So close. Yeah, interference, and all those things, reflection, he will continue to discuss. But the young double slit experiment is basically light from a point source has been made to fall into two slits, and what happened in the screen is that we see like periodic light and dark band on the screen. And they can be spaced, and there are some condition in the like width of this and all. So before the wave theory of light, there was Newton's corpuscular theory of light, and Huygens had given the wave theory of light before the Newton. But at that time, Newton was so prominent in the scientific theory, no one believed Huygens. After a century, Young's with this double slit experiment proved that light nature is indeed a wave, the wave nature. Because otherwise, if it light used to follow the corpuscular theory, so we would not be seeing periodic bright and dark bands on the screen. So basically, the source here, this is a point source, and every source emits wavefront. And the thing is, this two slit are equidistant from the source. Okay, this is for that reason, these two slits, I have drawn a very big slits here, but they are actually very small in nature. So these two slits are on the same wavefront. So they act as a secondary source of light. And when these two waves When these two waves interfere with each other, they form these bands. So, you know, so this is a wave. The maximum of the disturbance is called crest, and the minimum is called trough. And so it has been like portrayed beautifully in the PPT of the class that for if two waves interfere constructively, interference, we will get result this. But if they interfere destructively, but like this, they will annihilate each other. So depending on the distance, like here, if here two waves interfere constructively or the distance is n lambda, then it is constructive interference, this distance, like this distance. But here, the distance is destructive distance. So if like distance in them is d1, d2, the path difference d2 minus d1. The path difference equal to n lambda or 2n lambda by 2, then this is constructive interference. But if it is 2n plus 1 lambda by 2, then destructive interference. So more discussion in the interference will be done in this way. Lecture videos have been uploaded already, and to go through and see what is the interference and things like this. But for now, this is the gist of the concept that we discussed. Now, go on to some MCQ questions. First, I will discuss a question from the previous year. Then I will go into some different questions. First question is population evolution in a two-level energy system. Can be created by option 1, raising the temperature. That is like kind of it would seem like kind of possible because of gas dynamic pumping, but this is does not only involve raising the temperature, that is also cooling the like cooling the system also, like lowering the temperature both at the same time. But the key thing I'll discuss the temperature. Option 3 is by means of optical pumping. Option 4 is none of the above. It would be none of the above because we cannot achieve population inversion in two-level energy system. Okay, if it would be three-level and all those things, then optical pumping would be the answer. Question 2. Excitation of atoms in an electric discharge is the result of one, elastic collision, 2, inelastic collision, 3, both elastic and inelastic, both of inelastic. 4, none of the above. So this is because of an elastic collision. And if the electrons give their kinetic energy to atoms, that's how pumping possible by electrical discharge. So this has to be an elastic collision. Question 3. What is the challenge posed by system in achieving population in source. First one, source level is different from the lower level. second source level and lower laser level are common. Third, upper laser level and palm level are different. Oh, but different. Upper level does not readily de-excite to the palm level. So we know the problem in the three-level nervous system is the lower laser level and the source level was the same. So that why to keep the population inversion that was difficult and expensive. So that is the answer. Population inversion can be achieved by achieved in an ideal four-level system by transferring 50% of from source to upper level. Secondly, transferring 33% of species cells from source to upper level. Transferring negligible population of species from source to upper level. Population inversion is intrinsic. So we know that in the 4-level level system, this one is already empty. So if we even transfer one atom or ion from source to upper level, that will do to start the population evolution and start the living population. So this is the answer. Question number 5. Most of the reflection encountered in nature are so specular, isotropic, non-specular, all of the above. So basically, we see shiny and non-shiny objects, but most of the objects are non-shiny. So non-shiny objects we see because of the non-specular or diffused reflection. So this is the answer. That's non-specular. And 6. What is the question? What is the reflection from air class interference and normal angular incidence where relativities of air is 1 and class is 1.5? I have done, but now I remember I have done mistake. So this is 0.2 whole square. So that means 0.04. That is 4%. So only 4% is got reflected. So options are 1%, 2%, 4%, 8%. So 4% is the answer. Question 7 is in young double slit experiment, so in the term of interference, be it young double slit experiments or multiple beam interference, energy and momentum both are conserved. So the correct answer is because the energy got redistributed. All the energies are in the bright spaces. The redistribution of energy occurs. That's the correct answer. Question 8. Some basic reflection questions. Ray of light is traveling from medium A to medium B. What is the refractive index of medium B to medium A? So this is how the light is traveling. This is 60 degree, this is 45 degree, this is A, this is B. So I'm not giving the so option is 3 by 2. Option B is 2 by 3. Option C is 1 by 3. Half D is 2. So we need to calculate the refractive index of B with respect to A. When we need to calculate refractive index of one medium with respect to another, so velocity is opposite. So velocity of medium 2, of which we need to get the refractive index. With respect to, we need to refractive index that velocity by v1, of which medium we need the refractive index. That means n1 by n2. That means by sine I by sine r here. So sine I here is sine 60 degree and sine r is sine 45 degree. So that means 3 by 2 by 1 by 2. So that gives us 3 by 2. That is the answer. Question 9. The refractive index of water is 4 by 3 and that of glass is 3 by 2. What is the refractive index of glass with respect of water? So the options are A 1.1, B 1.23, C 1.25, D 1.125. So basically, mu1, 2 can be written as air, mu1, air. Okay. 2, 1. So here mu, water, glass. So we need to obtain the refractive index of glass. So glass is here with respect to water. So basically here we need water, glass. So that will be 3 by 2 by 4 by 3. So 9 by 8, that is 1.125. This is the answer. Okay. Question 10. So very easy question. First another question. A ray of light is incident at an angle of 30 degree at a water glass interface. Calculate the angle of refraction given mu ag air class 1.5 a water 1.3. So I'm like the mathematics is so no UAG maybe a water is basically sine IW sine I class. So sine I class. So basically we are given two refractive index. So this is refractive index is from where? From air to glass, and this is air to water. We have to calculate water to glass. So sine I water is sine 30 degree. We need to calculate sine I, the glass. That is 1.5 by 1.3. So from that we calculate the angle in the glass will be 1.3, 1.5 into half sine inverse. So angle of refraction is 0.446. So that is 85 degree 41. So this kind of questions will be there. The quiz. That is for today. Next class may not be happen on Friday. That actual date will be announced in the portal. Thank you.